So tonight he's going to talk to us about security, startups and data science. So, thanks Dave.
Yeah, that's pretty much it. I'm not a director of engineering anymore. I'm just a poor old young data scientist in Engineered. That's my talk, because I'm really fucking lazy. So, I'm going to talk about a few things, right? I'm going to talk about data science. I'm going to try to explain a little bit what it is. Then I'm going to talk about some of the technology I use, some of the things that are important, or some of the security problems you might have in a startup, and some of the ways we've resolved them in Engineered using big data, and then some of the ways that I'm solving it in my next startup, which I'm starting next month. So data science, how do I start again? So, well, I disagree with there's a definition of data science, which is basically extracting or generalizing information out of data. That's data science, but the science is the operative word. And the thing that's missing is that data science is not one thing, it's a set of things. The only thing that it has is science. And about, I'd say 2 years ago at this point, there's someone that called DJ Patil, who's my online friend, and he coined this term called the data scientific method, which is very similar to the scientific method, and for most of you who probably don't remember that from secondary school, it's pretty boring, but I'll give you the data scientific method, which I can't remember by heart, but yeah. You basically start, you have to find a question, and that's kind of funny because I'd say 40% of my work in Engineered is trying, or work in any data kind of environment, is trying to extract one question out of someone. When they say, oh, I need to do this! I'm like, okay, what do you want to ask? And then we spend time, and then it's always why. What, when, why? And then after a day of hatred and mutual destruction, what we end up doing is, all right, so you have one question, we can start looking at things. And the second thing you do is you look at the data you have now. And it's really, really easy for most data scientists or most data enthusiasts in any companies to kind of try and like, oh, I could get more data from here, I could get data from here, I could aggregate these things. But what's actually really important, especially in a startup, is try to look at the data you already have, because most of you, or most of people that have some sort of app or some sort of website or some sort of anything, you will have data. You might not know you have it, but you have it. It could be Google Analytics data. Turns out pretty important data if you can mine it properly. Then once you have understood your data, what you have to do is something called feature engineering. And well, it's basically developing features out of your data. So to make it a little bit simpler, to explain feature engineering, it's let's say you have a lot of dates, right? People that signed up and people that convert when they gave you their credit card or when they started paying you. And you can either analyze a long series of continuous information on dates, or what you could do is look at the sign-up dates, look at the conversion date, and start putting things into buckets. So you can say, all right, so that's the group within 4 to 12 weeks that signed up. That's the group between 12 and 24 weeks that signed up, that converted. And it seems very stupid when you say it, and when I say it that way, but turns out on the way of analysis, when you actually look at the data, it's extremely important to be able to extract a second meaning from the data you have. So one I really like is, for instance, email addresses. Some people would look at the domains, and some people would look at, say, the domain frequency. Let's look at our users and which ones are real, which ones are real users, which ones are not. And what I decided to do one day, when working on battling fraud, was, all right, so let's look at instead of the domain and the email address only, what we're going to do is look at the structure of the letters. So the username, the part before the @ symbol. So we started making predictive, well, not actually predictive at this point, it was just mathematical models of the distribution of letters and how they repeat each other to kind of identify which users seem to be more fraudulent than others. So see, what we did is we didn't only use the username and then made a huge bucket. What we did is we extracted another level of information out of the information that we had. And that's the part in the data scientific method where you start your question, you look at the data you have, you try to exploit it, then you develop features and you test your assumptions and your ideas. And the first round of your hypothesis testing essentially is going to be analyzing your results. And that's the fourth step of the data scientific method, is analyzing the results. And it's not going to be pretty. And your feature engineering that you did in 2 steps before is going to look pretty shit. But then, on the other hand, what you do is you start, you analyze the results, and then what you have, which is the most important thing, they don't seem to teach that in school at all, in any type of mathematical schools or any type of data analytics kind of courses, is you need to have a conversation with the person that asks you the question. And this conversation needs to be framed by the data. It's not a discussion about the data, it's a discussion you bring to the person that wants the question answered, that you bring the discussion based on your shitty first results of your analysis. Then what happens after that? You keep doing the same thing. Okay, is the question answered? No, let's look at the data we have. Do we have to re-engineer the features? Do we have to try to find more data? And you keep going like that until you actually have an answer. Now there's a problem to that. In order to have a good extrapolation of information from your data and a good analysis and a good discussion, it implies that you need good data scientists. Pretty hard to find because no one really knows what it is. Forbes said it's the sexiest job of the 21st century. I assure you it's definitely not. It is being like a janitor. In fact, I'm a janitor / cat herder because usually it's trying to have conversations with people which don't want to have conversations. They just want all the answers to no questions. And then the other part of it is cleaning the data that you have, that you already store somewhere, that is dirty as crap, that you have to try to make things work together. It's basically making mountains out of molehills. But anyways, to get a good data scientist, you need someone who can actually write code, so someone who can hack. Then you need someone who has a good maths background, good stats background, probabilities, that sort of stuff. Then you need domain knowledge. Domain knowledge is so important, but people usually don't say it. If you only have someone who knows how to write code and algorithms, and he knows the underlying structures of the mathematical models, what you end up with is someone who does really good machine learning, and it's extremely powerful. Now, if you bring the third aspect, which is the domain expertise, that's where the intersection of these three skills, that's where data science happens. Because from the domain expertise that you brought into your analysis and your code that is actually performant, what you have is you're starting to answer questions. And you're starting to answer questions that are actually directly relevant to your business, and that is extremely important. And for most startups, the data scientist is usually going to work directly with the CEO or the executives or the board even. And there's one thing that's missing from this skill set, and it's business doc. And it's pretty annoying, but you need to kind of be able to communicate with CEOs as you will be able to communicate with customers and engineers and everyone else. Business doc's pretty easy to learn. You don't need an MBA to do this. Pretty straightforward, but I'm not gonna do this. I'm not gonna talk more about this at all. So now, what's this? I don't know what I wrote. Shit. Last 2 years. Oh yeah. So last 2 years at Engine Yard, I've been a data scientist on the security team, and we're the largest pass provider in the world, the public pass provider in the world, sorry, private pass provider. We're not a public company. And what we've done is security in startups is so complex. There's so much shit that happens. You have, antivirus for the computers of the people in the company. You have your apps that are on servers, that are on networks. You have your database servers. You have everything that's on the cloud. And then you have, insiders in the company that might be shooting out data, and you have so much information. For us, one of the biggest thing, which turns out actually to be 10% of our whole revenue that we saved, is fraudulent behavior. Not fraudulent users, but fraudulent behavior. So it was actually an experiment one day. I was just looking at a bunch of data and I was like, all right, let's see if I can find something. It's like, this is really weird. So fraudulent behavior is something that came out of, what we did is we looked at all our users and we kind of started putting them into clusters, okay? So that's people that signed up 3 months ago that then they converted. Then what they did is they launched their first application server, and then we're like, okay, so that path seems normal. What is this one? Why do they have bigger machines, but they converted really quickly, like within 3 days, but their credit card validation worked and all this stuff kind of worked. And then what happened, what came out of this was a bunch of patterns for fraudulent users, essentially. So in a startup, usually you won't think about this sort of stuff. Fraud is so complex. And talk about fraud, let's talk to CorkDev. They know how complex fraud is. We're actually bringing in CorkDev now in Engine Yard because we had that issue. And what we're going to do is we're going to put them in front, so they're going to analyze the people when their credit cards come in. And then what we do is we then analyze their actual behavior, like the behavioral analysis of the actual users. And how much time do I have left?
I'd say...
Sweet. I'm not going to listen anyways. The next thing I did, blah, 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 blah. Oh, yeah. The other thing that was actually funny, which inspired me to start my next startup, is intrusion detection. So in Engine Yard, we have something like, 27,000 servers, I think, at some point or whatever. And we installed intrusion detection systems on all of our machines. And intrusion detection systems are extremely fucking complex to set up. They're expensive to use. The open source ones, they're open source tools. They just don't have all the business that's surrounding them to provide you with better tools. So what actually ended up happening is, as we're looking through the logs, because you have to try to find a way to get all these logs aggregated. It's really hard to maintain. We found out that as soon as we put an app out, within 7 minutes it would get attacked. Within 21 minutes, 21 minutes it would get, well, the ones we caught were cracked, and then 3 months after that, we wouldn't see anything for 3 months, and then something would start happening from these machines. So from the intrusion detection, we actually improved the fraud engine, like the fraud behavioral analysis. So we looked at patterns of traffic. If different types of users are in certain buckets, what's their traffic pattern? Should they be using that much CPU or that much memory on their machines at that time of the day? What ended up happening was we just have a huge engine now that sucks in a lot of data, and it tries to do this. It's not real time. It's a typical Hadoop setup. It's like post ad hoc analysis. And then we have reports every every single hour that kind of happen to this. So from this, I started my next thing, which is barricade.io. And you should definitely say something on Twitter, hey, barricade.io. And what we're doing is pretty much that. We're doing intrusion detection as a service, not prevention, detection. And what we want to do is simple. It's real-time, extremely lightweight agent that you install across your servers. You don't have to maintain, you don't have to do anything. And within minutes, you can start seeing kind of alerts happening and all these things. You get notifications and all this stuff. The thing that's funny now, I'm going to throw in a few words for this because real-time artificial intelligence is extremely hard to do. Near real-time is pretty easy. And when it comes to network packets, because that's what we analyze all your network packets all across all your servers, and we detect anomalies, we detect data breaches, we detect what comes in that shouldn't happen, we detect attacks and all these sorts of things. The idea is that you install the agent, you're ready, but the real-time part, Hadoop has made MapReduce like the de facto standard for kind of running large jobs of analysis. For you that don't know MapReduce, look it up, and your brains will probably explode. But in the last few years, the technology kind of evolved really quickly, especially big data processing kind of, I hate the term big data, it should be big questions, but that's a different issue. The whole idea of processing data really fast, LinkedIn, Twitter, all of those big companies, they had to fix that problem because they have hundreds of millions of tweets a second kind of thing. And that's what we're using. We're using something called Kafka, which is just a queue. So as soon as there's data that comes in, we can't lose a single packet. It's extremely important data. So we just put everything in a queue that's replicated across 7 servers internationally to make sure that if there's an earthquake somewhere, then we can still pick up the queue. Then it goes through something called Storm. Storm allows you basically to do MapReduce in real time, which it's an oversimplification of Storm, because Storm also another thing that when you Google it, your brain's going to explode. And then guess what? It goes back into Kafka, into the queue, so we can pick it up after. And that's not even the database yet. That's just like the analysis to identify if there's an event happening, an anomaly that we have to detect. That's the machine learning, the artificial intelligence. That's the engine that detects malicious intent. Once it's out of Kafka, after the Kafka, Storm Kafka, it goes into Cassandra, REAC, and then it goes into Elasticsearch, because there's different types of data, different types of questions you need answered at different point in time. Some data is super important to have real time, some other data is not that important to have now. And that's kind of what we're doing. It's the whole way of manipulating data, large amounts of data really quickly is absolutely fascinating. And if you want to talk about this, feel free to barricade.io me on Twitter, or my name, which no one is going to be able to spell. And yeah, it's just